Okay, you ready? Here we go. Achoo! Oh, my eyeball. Oh, gosh. Oh, that's... Okay, that's better. All right, here we go. Focus, 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 focus. Will this thing focus? Hello? Can we focus? Oh, man, it's horrible. Hello? Focus. There we go. That's better. Oh, kind of. All right. Okie dokie. Let's look at my two equations that I got here. I got x squared minus 8x plus 16, which I had in the last episode. And so we're going to type that sucker in, which I've already done. And then I'm going to make sure I'm zoom 6 in this bad boy. And here it comes in blue. Bam, bam. Now we want to know stuff like axis of symmetry. Well, the vertex is on the axis of symmetry. So we're going to use our second button and trace to go to calculate. And let's find ourselves, oops, wrong thing. Second calculate. Since this one opened up, we're looking for a minimum value. Okay, there we go. We're asking for a minimum. And then as you know, we've got to use our little scrolly things. Here it is. To give it a range of values to look from. So I'm going to get close to the lowest point and give it a left bound. Use my little arrows to scroll around to the right side to give a right bound. And then I'm going to go put it kind of close to what I think it is and hit enter. And that means it's at 4, 0. 4, 0. Y-intersect, we can do that too. And the way we're going to do that is we're going to push trace. And we're going to want to trace it where x equals 0. So you're just going to type in at this point 0 and hit enter. And you can't see it in the picture here, but that cursor is up there at 0, 16. If you'd like to change the window, you could do that. Maybe I'll put this at like a -2 and go up to 20. Then I can see. Oh, that doesn't make any sense. Why did I do that? Yeah. Let's go and change that window again. Window. Let's keep that -10, 10, but we'll move the y minimum to -2 and the y maximum to 20. So now I can see that intercept. Here it comes. It's going to cut across, go down there, come back up. Trace 0, 0, 16. There it is. If we would like some other points, I already told you we can go second table. And you can scroll through points. These ones don't make sense. These ones down here do. Look, we got a whole bunch of values that we could graph on there. You could graph 1, 9, 2, 4, 3, 1, 4, 0, 5, 1, 6, 4, 7, 9. All those are very graphable on one of our stampy things there if you needed to do that on a piece of paper. What else? Any other 2 points? Connect the dots. We've got all the goods there. Now let me do one more that, turn that one off, turn this one on, that opens down. You can see that because the A there is -3. So this one must open down. I'm going to zoom 6 this bad boy. And here it comes from the bottom up and over. And there we go. So if we would like to trace out some of these points, like maybe the vertex and the axis of symmetry, this one has a maximum. And we're going to do the same thing a little bit to the left and a little bit to the right. It's going to look for a highest point. And it tells me that that maximum is at 0.833333, which is a weird decimal. But if you look at the original problem there, it was -3x squared plus 5. If we used our axis of symmetry equation, it would be -5 over 2 times 3. So -5/6, right? -5 over -6. So 5/6 is what that point happens to be. Let's go back to trace. Okay, go back to trace and we will decide, how about that y one? We'll go trace 0. When x is 0, what's y? Y is 7. There's that one. We can pick some other points by going second table. And we've got a whole plethora of extra points that we could use if we so choose to. What other stuff can I show you on this? This one, zeros. Zeros are where it crosses the x-axis. So we got to go a little before we get there and give it a left bound and then give it a little bit past the 0 for a right bound. And we're guessing that it's somewhere in there. And this says that a 0 is at 0.906718. But wait, there's more. It has 2 zeros. So let's go and find the other one. The other one is between this point and this point. It's more like that. And this 0 tells us, well, that's like it. That means 0. About 2.57, blah, blah, blah. I'll go back to the other one and do that business with it because it might come out a little bit cleaner, or maybe not. Graph that one again. It's going to come and gonna get close to that x-axis. Just touches it, maybe just kisses it. Let's go ahead and double check and look for some zeros here. Our left bound will be right about there, and our right bound will be about right there. And I'm going to guess it's down here. And it tells me, yep, it's got 1 0 at 4 0. One extra way to check on these things, if you go to your apps and then go down here to number 9, Polynomial 2, we have this beautiful thing called Polynomial Root Finder. Remember, roots are the same things as zeros. And these are order 2 because they're x squared types of problems. And then I just go to next, and I'll type in what the equation was. And this one was 1x squared and negative 8x and 16. And then I push this button that says solve, and it says the zeros are 4. Twice. Because it only touches it once. So there you go. You can do that with any polynomial equation, any quadratic. You just give it A, B, and C, and it will spit out the answers. Or, you want to see something really cool? I've written a program for quadratic equations. And all you got to do is give it the A, give it the B, and give it the C. And it does the math, and it even gives me a high five. Nice job, mate. We're all done. Okay, so we're all done. Hope you enjoyed that, and happy graphing.